Okay, for Math Olympiad test number 5, problem 5C, notice that for the first two I was writing them up as 4A and B, but it's actually 5A and B. But on 5C, we have a money problem, and the problem says that Tracy has A quarters and B dimes, and the total value that she has is $3.45. And then she has more quarters than dimes. And then the question is, how many different values of A can Tracy have? And at first, this question can be a little bit confusing because is she, since we have A quarters, are they asking how many quarters does she have? But it says how many values of A can she have? And I think this answer is going to, or the concept regarding that question is going to become a little bit more obvious as we work through the problem. And in the strategy, actually, let's go through the questions. The problem is a money problem. Okay, it has to do with money, counting money. Okay, and we have quarters and dimes, and we have a total. Okay, and so let's begin by defining what these things are. Okay, in order to count money, we know that 1/4 is going to be 25 cents, correct? And then we know that 1 dime is going to be 10 cents, okay? Now also we know that $1 is going to be, it's going to be 4 quarters, okay? $2 is going to be 8 quarters, and we know that $3 are going to be 12 quarters. Okay, now so we're going to try to compute how many quarters and dimes pairs. So we're going to be looking at the combinations, how many pairs of quarters and dimes are compute $3.45. So let's do this. Let's look at the number of quarters, at the number of dimes, and let's look at the total. Okay. So let's see if we can do this. Now, let's go back here and look at the total. We know the total is $3.45. Now, the 5 there, okay, is telling us that it's there has to be an odd number of quarters, because quarters go 25 cents, 50 cents, 75 cents, but dimes are 10 cents. Dimes are always even, quarters are not, right? So we know that there has to be an odd. Here's for a pattern. Okay, so we're looking at let's look at the patterns. So we also know that there has to be an odd number of quarters. So we know that 12 quarters are $3. But if we add, how do we get to $3.45? Well, that will be here. So we would have to start out with 13 quarters. That will be $3.25 plus 2 dimes, which is 20 cents. We arrive to $3.45. So that would be like the first combination. And that would be the absolute maximum number of quarters that we can have. Okay. And also notice that it says that she has more quarters than dimes. And it's curious that that satisfies that here in this case. We do have more quarters than dimes. We have 13 quarters and 2 dimes. So then the next number of quarters that we could have, it has to be an odd number. It would be 11. Okay, so 11 quarters is $2.75, right? So to calculate the number of dimes, we could do $3.45 minus $2.75. Okay, so that will be 0. We borrow 70 cents or 7 quarters. I mean 7 dimes. So 11 quarters plus 7 dimes equals $3.45. Okay, we still have more quarters than we do dimes. Okay, great. So let's keep going. The next number down, since 13 is the absolute maximum number of quarters, then the next one down is 11. Naturally, the next one down is going to be 9 because we have to have an odd number of quarters. So how do we come up to $3.45? So we know that 8 quarters is $2, so 9 quarters is going to be $2.25. And so in order to find out how many dimes we need, we can subtract $3.45 minus $2.25. So that will be 0, that will be 2, and that will be $1.20, which is 12 dimes. Okay, and then so on and so forth. And the next one will be 7 quarters. So 7 quarters would be $1.75. So $3.45 minus $1.75 would be $1.70, which is 17 dimes. And this still adds to $3.45, so on and so forth. But, okay, the problem said that she has more quarters than dimes. And then the question is, how many values of A? How many values of quarters? And I think that what they're really asking is how many combinations that satisfy that condition, which in this case is going to be these two. So the answer is 2. 2 combinations of A. 2 combinations of quarters, 13 and 11, satisfy the condition that she has more quarters than dimes. So that the answer to the problem is 2 combinations. Thank you.